Okay, guys, I apologize for being absent again. Trust me, for this one, I would much rather be at school with you guys. But things in life happen, and I do apologize for not being able to be with you guys today. I am going to give you a little video on using equations that you need to solve using graphing to help you solve those equations. We will look at this also a little bit in another way in the next chapter that we look at. But in this chapter, we're looking at single variable equations like negative 3x plus 20 equal to 5. And I know that you can solve this by subtracting 20 and then dividing by negative 3. But we're going to look at another way of solving it by graphing. I am going to allow you to utilize technology a little bit more in this section. So you will be able to use the graphing calculators in my class, as well as being able to use Desmos. So this will probably be on a separate page when it comes to your test in class. So notice it says, how can you use a graph to solve an equation? If you have negative 3x plus 20 equal to 5, one option for solving this by graphing it is to take each side of the equation and set each side of the equation equal to y. Essentially, you're taking that negative 3x plus 20 and that 5 and separating them into two separate equations that you can graph on a coordinate plane. So y equals negative 3x plus 20, y equals 5. Two new equations that we are going to graph on the coordinate plane. Now, negative 3x plus 20, just as a quick little review, remember the beginning amount is 20, and the slope, or what you move by, is negative 3. So you would begin up at 20, way up here at 20, and then you would go down 3 over 1, down 3 over 1, down 3 over 1. Now, guys, obviously I'm not going to make this graph very detailed because I want to give you a better graph. I'm going to let you computer show you the graph here in a second. Y equals 5 would be a horizontal line that goes across. So what you have is you have two separate equations by taking the two sides and making them into two equations. What that does is that gives me the ability, like I said, to graph each one of those equations. Now, obviously, this one is the negative 3x plus 20 because it begins at 20. And it's going down 3 and over 1, down 3 and over 1, down 3 and over 1 the whole time. We might graph ours slightly different if we were graphing it by hand because we might take this and count by different numbers than 5 each time. Notice that y equals 5, like I said, is a horizontal line. Do you notice that both of these graphs touch each other right here? In other words, they intersect. So they intersect at a point it looks like to be the point 5. If you zoom in on this, you should be able to see that. You could zoom in and see that 5 definitely is the point right here where they intersect each other. Now, technically, that point has a y value also. Is the point 5, 5, if you look at it, because it's right 5, and then remember we're counting by 5s on the y-axis, so it's technically the point 5, 5. But what were we looking for? We were looking for the x value that would make negative 3x plus 20 equal to 5. We weren't looking for the y value that they would be the same. We were looking for the x value that would make them both be the same. Now, it does have to be the same y value, but if you look, x is really what we were trying to solve for in the original. So x equals 5 should be the solution to this equation. Now we can go back also and look at our previous skills that we learned in the previous chapter. Meaning we could subtract 20 on this side, subtract 20 on this side, and that would give us negative 3x equals negative 15. If you divide by negative 3 on both sides, you get x is equal to 5. There's the answer. So graphing an equation, graphing one side and graphing the other, gives me a solution that works for both of those sides. Guys, remember, when we graph a line, every point on the line is a solution. So if we graph two different lines or two different sides of the equation, we can find a point that works for both of them. Specifically though, like I said, we weren't looking for the y value. We were looking for the x value that would make both sides the same. So, we're going to take a look at some examples of doing that. One example, the next one we have here, is the absolute value of x minus 4 and 1/2 x plus 1 by graphing. Now, I'm going to do a quick sketch because this is also going to help you review some of the stuff we've been talking about over the past two chapters, and especially this chapter as well. The absolute value of x minus 4. If I were to graph that using my skills that I've been talking about the past few classes, notice that's an absolute value, which is one of those V-shaped graphs, and it's minus 4, which means it has moved to the right 4 spaces. So if I came over here to the right 4 spaces and put my V-shaped graph across here, that would be what my graph for this side of the equation would look like. If I had the other side, y equals 1/2 x plus 1, it would begin at 1, begin and out. My slope is 1/2, so I would go up 1 over 2, and then I would draw a line that connects those dots. Now, obviously, I was sketching these, so I wasn't doing a great job with keeping my numbers exactly right. It looks like it's going to cross right here at the point 2, 2. So let's use our technology to make sure that is actually the case. So if you look back over here, like I said, y equals x, absolute value of x minus 4 would be an absolute value that has been moved to the right 4 spaces. Sorry about that. I'll try to slide this over here. And it's not going to like me. Come on, graph. There we go. So you can see that it's an absolute value that's been moved over to the right 4 spaces. And then 1/2 x plus 1, notice it begins at 1, and then it goes up 1 over 2, up 1 over 2, up 1 over 2. Make sure you pay attention to what you're counting by. But notice, like I said, right here is where the two graphs intersect each other. That point is the point 2, 2. But notice something that we also probably didn't see on the last one because of the way we drew the graph. Notice there's also a point here at 10, 6. Whoa, wait a minute. Does that mean there's two answers? Yes, that's what that means. So if you look at this solution here, you will notice that it tells me that I have two answers. One is when x is equal to 2 right here. And then another when x is equal to 10. Why does it have two solutions? Think about it. This graph makes this V shape, so a line cuts across it and hits it twice. That means there's two locations where this absolute value would be the same as this linear equation. So when we are solving by graphing, what we're doing is we're looking for those intersection points. We're looking for what x value makes each one the same. Now, technically, we could go back to some skills we talked about with absolute values and say that we could set x minus 4, which is inside the absolute value, equal to the positive version of 1/2 x plus 1. And we could also say that x minus 4 could be equal to the negative version of 1/2 x plus 1, meaning I take the opposite of both of them. If I solve this equation, I would get these two answers right here. But for most of us, this right here would be a little bit uglier than just learning how to graph this, and seeing where they cross. So graphing is not just, again, like Mr. Harrison said a few times, it is not just for making pretty lines across the paper. Graphing is there to help us find solutions, because the graph of x minus 4 in the absolute value gives us a bunch of solutions for it. 1/2 x plus 1 gives us a bunch of solutions for it. But these 2 points are solutions for both of those equations. So one possibility, whenever you have an equation with x, is to graph each side separately and get the solutions for that equation. Or sometimes only one solution. So let's keep practicing a few times. So if you were to take, zoom out a little bit more here. If you were to take something that looks like this, 5x minus 12 equals 3. So what we're going to do is I'm going to show you how to use Desmos, because this is a little Desmos screen here. But I'm also going to show you how to use our calculators, our TI calculators in class. First, we're going to go with Desmos. So if I were to take 5x minus 12 and set it equal to y, that would be y equals 5 times x minus 12. I can just type that one into the calculator just like I normally would in a normal calculator. Just type it in using my keys on my keypad. So notice it graphs that equation for me. And then I want to know when it is equal to 3. Or in other words, I want to know when it crosses the other graph, y equals 3. Take both sides of the equation to figure it out. If you're on Desmos, you'll notice that if you need to, you could zoom in a little bit, or you could zoom out a little bit, whatever you need to do. On Desmos, you can also come over here and notice that if I click on that line, it gives me these little gray dots. Notice if I hover over that line, and it's not going to work for me, of course. So let's go to the actual Desmos. Let me come over here. Y equals 5x minus 12. Then y equals 3. I was afraid that was going to happen. So if you were to take each one of those and graph them, just like we did in the little Desmos screen here, I don't know why that's not working. It should work, but it's not actually liking me. If you click on it, like I said, you'll see these little gray dots. These little gray dots, if you hold your cursor above it or click on it, it will give you what that point is. So this little gray dot here is where the two of these functions intersect each other. So that is the point 3, 3. So what does that mean? That means the solution to this equation right here where these two graphs intersect each other is at the point 3, 3. Well, remember what we were trying to solve is when the x value would make them equal. So the x value is 3. Now, I'm also going to show you how to do this on the TI calculators. So on the TI calculators, what you can do is you can go to this screen that says y equals. So I can click this y equals button, And I can do something very similar to what we do when we are dealing with the Desmos calculator. I can type in 5 times x. My x is going to be right here in this little button, minus 12. Then I can type in for my second equation, y equals 3, and I can hit the graph button. Now notice my graph is all jacked up. If any of yours ever do that, you can go to this little zoom button right here, go down to number 6, which says zoom standard, and it'll zoom to a normal graphing screen, and you can see those two things cross. The problem with the TI calculators is you can't really see very well where these two cross. So there is a neat little tool that you can use. If you look right above this word, trace, you'll see calc. If you hit the second button and you hit the trace button to go to the calc screen, you'll notice on number 5 it says intersect. That will find where two graphs intersect each other. If you hit number 5, it will say first curve. Now obviously these are both lines, but the TI calculator talks in terms of curves. So it'll show you where you're at on the points, 0, negative 12. I'm going to hit the right arrow, and notice it moves a little cursor up across the line. The first curve basically means you need to be on this line, and it will be typically as soon as you hit intersect. I'm going to hit enter. Then notice it takes me to the second curve, or in other words, the horizontal line. I'm going to hit enter. The last thing it's going to tell me to do is guess. Notice when it says guess, that's when I'm going to move my cursor over and try to get it as close as I can to that intersection. Press enter, and it tells me that it intersects at 3, 3. That is the exact same thing that we found when we looked at it using Desmos. It would be the exact same thing that we would find if we did this by hand, because these are both linear. So when you have two equations, you can find where they cross. So if you have an equation that you want to solve, you can take this right here, set it equal to y, this right here, set it equal to y, and you can graph using technology to find out where they cross. The x value of 3 is going to be where they cross. Yes, there's a y value also, 3, but the x value is what I was looking for at the beginning. Yes, guys, I still agree that if it's something as simple as this one, you may just want to add 12 on both sides. Get 15. Divide by 5 on both sides. Get 3. It gives you the same answer either way. What this graphing method typically is used for is to help us with things like we talked about on the last page, where you have a much uglier equation that you need to find solutions for. And it's got much uglier graphs. So it really helps you out when you run into one of those. So what I want you to do now is I want you to try this one. This one is in your online textbook if you want to use the Desmos function. You can also just use your workbook and try it. Still using Desmos if you want to graph the two equations. Or you can use the TI to go to the y equals screen and graph the two equations. And then when you get the graph, go to the calc function here to find your intersection. So I want you to try it. So pause the video and try it, and then I'll give you the solution. So what you'll see is that this side over here is negative times the absolute value. This side over here is negative 1/2 x minus 2. You take each one and you set them equal to y. So you're going to type in y equals a negative. The absolute value, you're going to have to take these little Desmos tools that come on this little keyboard, go to Functions. It's underneath Miscellaneous Absolute Value. You have other functions in here too, like exponential and logarithmic and things. But we're going to use absolute value. Then we're going to type in x minus 2. Notice it gives me a function that is opening down because of the negative, and it's right 2 because of the minus 2 right here. Remember, those are those function transformations we talked about earlier in the chapter. Then I'm going to type in the other one, y equals negative 1/2. So I'm going to do negative 1 divided by 2. Then I'm going to hit the arrow to the right to put the x beside it. And then I'm going to hit minus 2. Notice that we can zoom in again if we need to and look at these points a little bit closer. But this point right here where these cross, what is the x value right here? You have this point that they cross on the y-axis, but that means the x value would be 0. And if you plug in 0 here and you plug in 0 here, you will get negative 2 on both sides. This other point over here is 5, 6, 7, 8, and then down to negative 6. Again, notice that it has a y value of negative 6, but the x value of 8 is the key one that we're looking at. So 8 is another solution for this one. So what you could do is now you could tell somebody, because of where these two graphs cross each other at 0 for x and at 8 for x, those two are my solutions for this equation. Again, if you wanted to, you could use the TI calculator. I'm going to show you how to do that. You could go to the y equals screen, type in a negative. The absolute value on this one is underneath the math menu. Guys, and if you don't know how to find something, look it up. Use Google if you need to. The absolute value of x minus 2. Then I'm going to type in the second equation, negative 1/2. My calculator's doing the little double tap thing again. Negative 1/2 x minus 2. Press graph. And you can see, just like we did with Desmos, where they cross each other. Remember, you can go to the Calc menu by hitting second and hitting the Trace button. Go to number 5 and find where they intersect. So the first curve is the absolute value. Press enter. The second curve is the line. Press enter. Then I'm going to move it as close as I can and try to see where the guess is. And that would be it. 0 for x, negative 2 for y. But remember, we're looking for the x value. The only thing tricky about the intercepts for the TI calculator is now I'm going to have to hit second, go back to the calculate menu again for trace, and do intersect again if I want to find the other one that's down here. So I'm going to hit my arrow a few times to get it down here kind of close to it. And then I'm going to press enter on the first curve. It's on the y equals negative 1/2 x minus 2, the line. Press enter. And then go down here like it says it asks me to do. I'm going to guess that it's close to there. And then it tells me that it's 8, negative 6, which is what we found, the same thing we found when we looked at it on Desmos. So what I will allow you to do is I will allow you to use Desmos or use the TI calculators to help you out on there. It'll probably be a separate page on the test. That way, if you want to use Desmos, I can count on you not using the good old Google feature to figure out answers of your other problems. So let's take a look at a couple more examples here of using graphs to help us solve. One possibility is to also use a graph to help us solve when something is greater than something, or in other words, an inequality. Now this one says x squared minus 4 is greater than 0. Now let's remember, x squared is that little U-shaped graph. X squared minus 4 would be taking that graph and moving it down 4 spaces. So you would have a graph that does this. And wow, Mr. Harrison can't draw, right? But you would have a graph that comes down 4, makes this shape. Where is this graph greater than 0? Wait a minute. That sounds like something we've done before. Oh yeah, it's when the graph is positive. When the graph is above the x-axis, that's when it's greater than 0. Because greater than 0 technically means positive. So, how do I find those values? Basically, I'm going to do the same thing I did with the domain and range stuff the other day. But what I'll need is I will need to have the graph a little bit prettier than what Mr. Harrison has drawn. So I need to find some numbers. So if you look, you'll notice that if I graph this actual graph and I use some pretty points here, that this graph touches the x-axis at -2 and touches the x-axis at +2. That means it is positive or greater than 0 above there and above here. So if you look, that is the same thing that we talked about the other day in class, where we use the interval notation to talk about where the graph is positive, where the graph is negative. So the graph would be greater than 0 above the axis. So that would be -infinity up to -2. Remember, starting this way and coming to here. And then 2 to infinity, starting at 2 and going this way forever. Another way to say it would be our set notation, where x is less than -2 or x is greater than 2, because any number you plug in this way is going to give me a value greater than 0. Any number you plug in this way is going to give me a number greater than 0. So for instance, if I took this and I plugged in 5, 5 squared minus 4, what's 5 squared? 5 squared is 25. What's 25 minus 4? 21. That is greater than 0. So any number this way is going to give me a value greater than 0. Any number this way would also work the same. So that's what we mean when we talk about this interval notation or this set notation, that the left side of the graph and the left side of the graph is going to give me positive answers. The right side of the graph and the right side of the graph this way is also going to give me positive answers. That's greater than 0. So you can use a graph to also help you solve inequalities. Sometimes, just like some of those earlier examples we did just a little while ago, you may have two graphs that you want to find out when one is better than the other or less than the other. We did that a little bit with our example with our cell phones the other day. So you have this example here of a motorcycle that is 40 miles ahead of a car. The difference, though, is the motorcycle is only traveling 40 miles an hour. The car is traveling 60 miles an hour. When will the car be ahead of the motorcycle? If you take it and you set up two little expressions, the car is traveling 60 miles an hour. That's 60 times x, or 60 times the number of hours. 40 times x is how much the motorcycle is traveling. 40 miles an hour is 40 times x. But the motorcycle is already beginning 40 miles ahead. The difference, though, is that the car is traveling faster. So we want to know, when will this be greater than this? When will the car pass the motorcycle? And so what we look at is we look at those two lines. We take 60x, it's going to be increasing up 60 over 1, up 60 over 1, up 60 over 1, up 60 over 1, beginning at 0. But the motorcycle is already starting at 40, beginning at 40, and then going up 40 over 1, up 40 over 1, up 40 over 1. But look at what happens. Right here, as the little bubble says, at 2 and 120, it looks like the point of intersection between these two. That means anywhere past 2 hours, the car has passed the motorcycle. So whenever time reaches greater than 2 hours, that means the car has actually passed. So I know we used x in our function here because it's hours there, but I just wanted to tie it back with time. Alright, so here's an example in your try it in your workbook. You could do this. You could also use Desmos to help you, like I said, or you could use the graphing calculator, the TI. I think Desmos is going to be a little better on these problems. But we want to know when x squared plus 6x plus 5 is greater than or equal to 0. So notice there it says greater than or equal to 0. That'll come into play in just a minute. So if I type in x squared, I type in x, and I go to my little menu here, and I hit squared, then I hit arrow here to go plus 6x, and then plus 5, you'll notice that this graph has some positive values, has some negative values like we talked about, and then it also has intercepts. So notice what I said earlier, the greater than or equal to 0 is going to be important here, because what's the y value here? 0. What's the y value here? 0. So the intercepts are actually also going to come into play on this one. But remember what we did was we looked at our intervals and we said that anything above there is positive, anything above here is positive, but remember to describe it using your x values. So when x is less than or equal to negative 5, remember that's the negative infinity up to negative 5, using our brackets, or when x is greater than or equal to 0, that is 0 to infinity. This is the x values. This is the x values that would make this greater than or equal to 0. Again, above the axis or on the axis in this case, because it does say greater than or equal to 0. So you can try this one as well. When is x plus 3 going to be greater than 7 minus 3x? This one has two sides of the equation, so set up two inequalities. Pause the video here and see if you can go through and find the solution. Alright, so here's your solution. Be careful though, you need to pay attention. On this one, the x plus 3 graph is the red graph. So when is that graph right there greater than the black graph? Well, greater means above, so we're talking about this portion of that graph. So notice that this point right here is the point 1, 4, where they touch each other. But the red graph is not greater than the black graph there. The red graph is only equal to. So when is it greater? Everything this way. So what's the x values? Greater than, what's the x value? 1. Or, like we said, 1 to infinity. Parentheses, because not equal to. So this graph right here is greater this way. That's why we use this as our notation to tell what the x's would be. Now notice if you solve this, if you add the 3x, you would get 4x plus 3 is greater than 7. If you subtract the 3, you subtract the 3, you get 4x is greater than 4. You divide by 4, x is greater than 1. That's what we got. So that domain stuff that we talked about ties directly back to solving inequalities even. So when we look at this, guys, graphing to find solutions is just another way to get the answers. All right. Now let's take a look at a very quick example. I'm not going to spend a ton of time with this, but sometimes if you get something that looks like x squared minus 4x plus 1, x minus 2, you're going to see that the points where they cross are not quite as pretty. In other words, here you should notice that when you're looking at this right here, it doesn't cross at a nice pretty point. It doesn't cross at a nice pretty point. That means one of my solutions, as the little boxes tell me, lies between 4 and 5. One of my solutions lies between 0 and 1. What you may have to do sometimes in that situation, if it was a real life situation that you were trying to find a solution to this, and you didn't have the calculator like the TI calculator, which we'll do here in a second, you may have to make a table and see, oh, right here, notice that right here, they're pretty close to equal to each other at either 0.6 or 0.7. If I want to find when they are equal, what I could do is I can make another table and plug in numbers that are even smaller in increments. 0.65, 0.66, 0.67, 0.68. That's going to require some work to plug those in. But notice now I'm narrowing in on answers that are a lot closer together. And then I could even go even further if I wanted to get an even more accurate answer. I could plug in 0.695, plug in 0.696, plug in 0.697, plug in 0.698. Now guys, when I say plug in, I mean using your calculator to plug this number in for x, get an answer. Use your calculator to plug this number in for x here and here, get an answer. And so then what you do is you would choose the x value that is closest to each other right here. I would say on this one, 0.697. Here's what I'm going to do though. I'm going to tell you when you run into one of these, this is pretty time consuming, but it's very possible to use. I'm going to suggest that you use the TI calculator. Here's why. On the TI calculator, remember, I can find where these two things intersect each other. So I can take x squared minus 4x plus 1, and I can type x squared in, x squared, oh my goodness, this stupid calculator. It's going to make me angry. Let's try it again. X squared, then we've got minus 4x plus 1, so I have minus 4x plus 1. That's my first equation. My second equation was x minus 2. So we take it and we type in x minus 2. And I want to find out where they cross each other. If I graph it, I'll see, like we did over on the notes section, that they cross each other, but it's hard to see where they cross. Here's where you hit second, go to calc or trace button, and you can find the intersection. You can hit 5. It'll say first curve, second curve, and then you can guess. We're going to guess as close as we can right there. Press enter, and notice it says 0.697, which is exactly what Mr. Harrison said using our table of values if we kept plugging in smaller increments here. So I think using the calculator on one like this is a lot better. Then you could also find this point as well right here if you needed to. To save a little bit of time, I'm not going to actually do that one, but you would go second, hit the trace button, and do your intersect again. So, as we look at this later in the school year, we are going to learn how to solve something like this without a graph. Because right now, you don't know how to do that when you've got an uglier looking quadratic, remember that is what this is, on this side, equal to x minus 2, a linear one on the other side. So this graphing method that we're using here is going to be very helpful right now until you actually learn how to solve this in an algebraic way instead of a graphical way. All right, so in your textbook, it goes into a little section on using graphing technology, which is like Desmos, or using the TI calculator to find out where two things intersect each other. So since we've already done that several times, what you may want to do is just take this section of your book and practice this one by doing it on your own and then clicking on the solution to see if you got it right or not. I'm not going to do that right here just because you may want to take some time to do that first. And then click on solution and see if you got it right. If you don't have your textbook with you, then you can find somebody else near you, tell them to go to example 4, and tell them to see if you got the answer right or not. So, what you can do also is underneath this section in your drop-down menu at the top, you can look and you can see some concept summary. Do you understand? Has some practice problems in your interactive textbook that you could go through and practice. There's also, this little Math Excel thing that has review problems as well as, apologize for that. The Math Excel also gives you feedback on whether you got it right or not. There's also this adaptive practice that adapts to how well you're doing. I have not been able to get this to work at my house, honestly. So if you want to try it, you could. Next time in class, we're going to take a look at actually doing maybe a little quiz on this, a little small little quiz. Also, if you'll look down near the bottom, there is a Virtual Nerd video. Remember, Virtual Nerd is the app that you can download that has videos on how do you solve a quadratic inequality by graphing. It also has a few other videos for every lesson. Remember, you can also download that Bounce Pages app. If you are struggling at home with your homework, you can download the Bounce Pages app. It'll help you take a picture of a problem that you're doing, and it'll take you either to the Virtual Nerd video that'll help you out, or it'll take you to a step-by-step explanation of how to do the problem. It won't use the actual numbers that you're looking at, so it's not like photo math where you guys cheat and get the answer. It's actually going to make you learn how to solve something or learn how to graph something by taking you through a problem that looks very similar. So, for instance, if you were looking at this guy right here, this particular problem that we were looking at here, it would take you would snap a picture of it, and it would take you to a problem that may look similar. They may give you a problem that's x squared plus 2x minus 1 equals x plus 4. And then you would learn how to solve this one, and then go back to this one and figure it out by what you learned. You can do that with your homework all the time. Also, remember, you can always come by and see me if you have any questions off your homework. I can also show you solutions. I can't post the solutions because of Pearson asking me not to, and because it's also not fair, especially if you're an A-Day student, for me to post it and then the B-Day students get the answers for free. So multiple reasons I can't post it. But if you need any extra help, come by and see me. I should be at school early every Thursday and Friday morning. I am there early on other days if you let me know you're going to be there. I'm always there on Monday, Tuesday, and Friday afternoons. And then on Wednesdays and Thursdays, I have car duty or parking lot duty. You can come out and see me at duty if you need to ask me questions. Please don't go home and not get it and then not come ask me questions. But make sure when you come ask me questions, you actually have questions to ask me. Don't just come to me and say, I don't get it. Because I'm going to say, what do you not get? But guys, I'm there to help you. Please realize that. So, good luck. I'll post the homework for this also.